Hi everyone, in this section we will make an introduction to OAuth and OpenID Connect protocols. In OAuth 2 protocol we have to use access token for authorization purposes, as it is designed for that by using roles, scopes and permissions. On the other hand, for authentication purposes we should use OpenID Connect and ID token. We will see the difference of OAuth 2 and OpenID Connect in the next slides, but let's first look a bit of OAuth terminology. Resource owner is the user that owns the resource. This user will provide the user and password as initial authentication to get an access token. Client is the site that holds a functionality that will require a user to authorize first. Authorization server is the server that holds the user credentials and is used to authenticate and authorize user and return access token and ID token. Resource server is the site that returns the resource to the client when client provides the correct tokens which obtained from authorization server. Authorization grants are the rights that is granted during OAuth. Redirect URI is the callback URL on the client side. Response type is code or token. That means we can directly return a token in case of implicit flow, for example. But it is recommended to use OAuth with the code. We will see the difference in the next slides. Access token is the token to use in authorization to reach to resource server. And finally, OpenID token is the token that includes user details and used to log into a system. Here are the OAuth 2 flows. Let's go over them one by one. In the authorization code flow, client redirects the call to authorization server with a request that includes a redirect URI and the response type as code. Can also include scopes like read-write to limit the rights granted to be checked at the resource server. Then user is asked that X client wants to access your Y privilege, and then if user confirms, he or she enters credentials. If credentials are correct, user redirected to redirect URI on client by passing a code. Client then make a backend call to authorization server with the code plus client ID plus client secret, where client ID and secret were obtained during registration of the client to authorization server previously. And finally, authorization server returns an access token. In the implicit flow, client uses the response type as token instead of code. And authorization server directly returns token instead of code after user enters credentials. So there is no backend call as in authorization code flow. Implicit flow considered to be less secure. Be careful with client-side attacks like XSS with this. Resource owner password credentials. In this flow, client sends resource owner's user and password to authorization server with a backend call. It is also considered to be less secure as resource owner's credentials shared with the client. Avoid using this, as sharing the user credentials with a third-party client is never a good idea. This is simple and good only for demo purposes. And in the fourth one, client credentials flow, there is no user interaction. It is machine-to-machine communication with a backend call by sending the client ID and client secrets. This one is used to provide some functionality from a server, but this functionality does not depend on a user. Here is the diagram of authorization flow, which is the most flexible, secure and recommended way to obtain an access token, and it requires a browser interaction. As mentioned in the previous slide, in the end it requires a secure backend call to authorization server, and an authorization server returns an access token and also ID token in case of OpenID protocol. After this point, client can use this token to authenticate or authorize itself to resource server on behalf of the user and ask for resources. And finally, resource server validates the token by getting the public key and checking the signature on the token, as well as checking the issuer, timestamp, and other custom claim validations that you may want. Let's also look at the OpenID Connect protocol details. As I said, OpenID Connect brings the authentication standards to OAuth protocol and fill the gap to authentication. It is an additional protocol on top of OAuth, where OAuth is designed for authorization with permissions and scopes. OpenID Connect adds ID token and user info endpoint, and also brings standard set of scopes for authentication to standardize implementation. We can use same flow with OAuth like authorization flow on the previous slides, and simply add a scope OpenID on the first request to authorization server. Then authorization server will return both ID token and access token. We can use ID token for logging the user in and making an account available for other systems, like also for example using single sign-on, while as said OAuth is for granting access to an API and getting access to user data in other systems. ID token can be used easily with microservices. First service gets OpenID and access token and provides it to another service for authentication purposes. It can also be used by a web application with a normal flow and creating a session on browser and placing the tokens as headers, so it can be a replacement to form authentication, for example. In Oauth world, GWT is the de facto standard token format. GWT has three parts: header, claims or payload, and signature. It is signed by a server private key and optionally encrypted by client public key. Client can send the public key along with the redirect URI on the first request to the authorization server. You can check more about GWT on gwt.io. Here we can see an example GWT token. In transient, base64 encoded token is used, and here is an example of encoded token also. Finally, for the validation of token, at least signature verification and issuer and timestamp checks are necessary. ISS claim, which stands for issuer, should be on GWT because GWKS URL, which includes public key to use in verification of signature, will be fetched by looking at ISS claim. So after getting and possibly caching public key for later usages, signature on GWT is verified. Checking expired claim, which holds timestamp, also important because if token is expired, it requires another token request, or at least a refresh token request if it is used. Apart from that, IAT can be checked, which shows the creation time and age of a token. Audience can also be checked on access token to identify the intended recipient of the token. It has a different meaning for OpenID Connect protocol, by the way, and is used to identify client that is requesting the resource. And it is mandatory for OpenID Connect protocol. We can also check nonce, which is an optional claim again. Nonce used to associate a client session with an ID token and can be used to do a check on the server that client retries to authenticate by checking the nonce claim and comparing with a request parameter or cookie on the request. This way replay attacks can be mitigated. However, the nonce should be recreated each time and it should be a cryptographically secure random value to prevent guessing it by an attacker. Finally, by parsing the token and extracting authorities from scopes and roles defined in the authorization server, server-side authentication and authorization checks can be done on method level and or resource level. We will see example role, authorization and permission checks when we are implementing OAuth and OpenID on our web client and resource server. Note that for client, validating the ID token's signature is necessary, as in resource server, access token signature validated. Alright, I will see you in the next section.